Hello everyone, I welcome you all to this digital classroom for the subject control systems. Today, let us solve one example problem which has been taken from the model question paper released by VTU recently. A unity feedback control system is given by an open loop transfer function g of s is equal to k divided by s into s plus 10. Find out the value of k for zeta equal to 0.5, and for this value of k, find the rise time TR as well as the maximum peak overshoot MP for unit step input. Also find TP and TS. TP is nothing but the peak time and TS is nothing but the settling time. So in this question, you have been given with the open loop transfer function GFS, and the damping ratio zeta is given to you. Zeta is equal to 0.5. So from this given data, we are supposed to calculate the value of K, as well as we have to find the rise time TR, maximum peak overshoot MP, and the peak time TP as well as the settling time TS. So the first step is to calculate the closed loop transfer function C of s divided by R of s, which is given by G of s divided by 1 plus G of s into H of s. In this case, as it is a unity feedback, H of s will be equal to 1. Substituting for G of s as k divided by s into s plus 1 in this expression, we get the closed loop transfer function as k divided by s into s plus 10, the whole divided by 1 plus k by s into s plus 10. For this simplification, we get the closed loop transfer function as k divided by s square plus 10s plus k. Now we have to compare this with the standard characteristic equation, which is given by s square plus 2 zeta omega n s plus omega n square. If you compare both the denominator of the transfer function, omega n square is equal to k, and the coefficient of s is 2 zeta omega n, which is equal to 10. So once after comparing with the standard characteristic equation, omega n square is k in this case, I can write omega n as square root of k. Similarly, comparing the coefficient of s, 2 zeta omega n is equal to 10. Substituting for omega n as square root of k in this expression, zeta will be equal to 10 by 2. I can write it as 5 divided by square root of k, where square root of k is equal to omega n, which we have extracted right now. And if you look into the question, you have been given with zeta is equal to 0.5. Therefore, given zeta is equal to 0.5, hence in this expression, let me substitute for zeta as 0.5. Therefore, I can get the value of k. Once after substituting for zeta is equal to 0.5, cross multiplying and squaring on both sides, I obtain k is equal to 100. So I have obtained the value of k, that is the first option. Now we have to calculate this value of k. For the value of k as 100, we have to find for the rise time TR as well as maximum peak overshoot MP followed by TP and TS. We know that omega d is equal to omega n into square root of 1 minus zeta square. Once after knowing the value of k, if I substitute here in this expression, omega n, which is equal to square root of 100, I get omega n as 10. So I can substitute for omega n and zeta in this expression. Omega n is 10 and zeta is 0.5. Once after substituting for both, I obtain omega d is 8.66025. Once after obtaining for omega d, we know the formula to calculate theta, which is given by tan inverse of square root of 1 minus zeta square divided by zeta. So substituting for zeta as 0.5, theta will be equal to 1.0472 radian. Once after obtaining the value of omega d and theta, we know the formula for rise time, which is given by pi minus theta by omega d. We can substitute for theta as 1.0472 and omega d as 8.66025. Therefore, I can obtain TR as 0.2417 seconds. Once after obtaining the value of TR, similarly, we can calculate for TP, which is given by pi by omega d. Pi divided by omega d is known to you, 8.66025. Therefore, TP will be equal to 0.3627. Next step is to obtain the value of maximum peak overshoot, which is given by e to the power of minus pi zeta divided by square root of 1 minus zeta square into 100. Zeta is known to you, 0.5. So I can substitute for zeta here in this expression and find the maximum peak overshoot. After simplification, I get that as 16.303%. I have obtained the value of TR, TP and MP. Finally, the settling time is given by 4 divided by zeta omega n. As zeta and omega n is known to you, you can substitute here for zeta as 0.5 and omega n is square root of k, where k is 100, therefore omega n will be equal to 10. Therefore, I get the settling time as 0.8 seconds. This is one of the problem which has been taken from the model question paper which has been released by VTU recently. In the coming sessions, let us solve few more problems from the model question paper related to module 4 and module 5. Thank you.